Problem 14.5 on page 483 is very similar to chapter 13, except we have multiple regression. In this case, you can see the quality is the output, is the Y variable, and we have all of these different inputs. Now, for our purposes, we could select all of them, the acidity, the citric acid, etc. The two that we're going to select are calories and alcohol. Only problem is they're not side by side. They're not continuous. So what I'm going to need to do is I'm going to need to put them in the same, put them side by side. So I'm going to insert a column here. I'm simply going to take this column. I'm going to put it over here. Doesn't matter which order you do, alcohol, calories, as long as they're side by side. So in this case, we're going to go to data analysis, regression, just like we did before. We're going to click on this column. That's our output, our Y output, I should say, or the Y range. The input is 2. We have columns K and L. The output range, I'm going to put over here. So I'm going to put the output range over here in O2. And then I'm going to go, okay. So I'm going to scroll over so you can read it. So how do we interpret this? Just the same way that we did for single regression. We look at the fact that y-intercept is 1.159. So if alcohol is 0 and chlorides are 0, we would wind up with a score of 1.159 for quality. We can see that alcohol has a slope of 0.4962, positive, and that chlorides has a negative slope of 9.633, which means the more chlorides you have, the lower quality you have. That's what it represents. So in this particular case, we have also the p-value. So that's the answers for A and B, by the way. And the p-value, which would tell us that the p-value is very low for both alcohol and for chlorides. So they are valid. In other words, slopes are not 0. The adjusted R or the R squared value is 42.5%. So that means this alcohol and chlorides only explain about 42.5%. That's called the coefficient of determination, if I haven't mentioned that before. Now, in part D, you would simply input, so in part D, you would input 10. So let me put this in here. It would look like this. You would have, I'll simply select this number. Actually, I'll just formula properly. Plus this alcohol slope, plus if the alcohol content is 10 and the chlorides are 0.08, I take this, multiply 0.08, and my expected quality is 5.35. So I'll type that out. I would have gone P, in this case, that is P18, I believe, plus P19 times 10 plus P20 times 0.08. I got, so that is the formula that I just used. In E, we would have, in this case, in problem 5, a 95% confidence interval for quality wines of ratings of 10% alcohol and 0.08. So we'd have to go through the confidence intervals like we did before. And you can refer back to chapter number 8. So that would be the answer for E. And then a 95% confidence interval for the prediction interval for the individual wines. That is in part F. So focus in on parts A through D. You can just simply use the confidence intervals for the, in this particular case, is specific. The confidence intervals we have is for all of the alcohol. So you'd have to find all the ones that, all of the data where it is the alcohol is 10 and the chlorides are 0.08. So you'd have to search for all of those. And we've done confidence intervals before.